video, we're going to take a look at proving figures are similar. And we're going to start with this triangle right here, A, B, and C. And what we're going to do is we're going to take a look at moving it over here. Is this one the same? And from A to A prime, what we're doing is we're just simply moving it. This is giving us our XY, which we've done previously, and giving us an output of X plus 7, Y plus 4. It's simply moving to the right 7 spaces and up 4 spaces. And when we can follow a translation just like that and give an input-output, then it is a translation and we're capable of proving it. And all we have to do is actually count how far to the right and how far up or left and down that it would move. Now if we were to take a look at this one right here, it looks like it's flipped over. And so what we want to do is we want to find that middle. And when we find that middle, what we're able to do is we're able to just simply say that this flips over this line. When it flips over this line and we see that what it is, then it means that the X has become negative. This is all back to some old skills on doing reflections. So the X has become negative. So we started with an XY. We're ending with a negative X. But if this flipped over, it would be at -3 when it's at -1. So I have to move it to the right 2 places. So plus 2. But my Y coordinates are the same, so I can say comma Y. So it's at this point that you need to go back and be able to review all those transformations that we had and how to be able to find them. When we look at this triangle, what I can do is I can see that this is rotated. It's turned somehow, but it's turned at 180 degrees. So this one right here, I would just simply call 180 degrees about, but I have to find the center of rotation. So the center of rotation we're able to find by putting in lines from this C to this C, A to A, and B to B, and that intersection point that is here is located at 1, 1. So it's a very fast system when you know your translations. Inside we have a smaller one, so we can see that it is a dilation. How much smaller would it be? So I would use my distance formula to find the distance of a side and then the distance of the other side to see if it does have a scale factor. So if AC to A prime C prime has a scale factor of 1/2, then I need to make sure that C to B and C prime to B prime have the same scale factor of 1/2, and A to B and A to B prime all have that same scale factor of 1/2. So we get a 1/2 scale factor. So this is going to give me an XY gives 1/2 of my XY. The problem that I'm going to occur if I'm occurring if I get this is that half of C is actually moving it in this direction. So I now need to be able to move it over and up. So I have to count those spaces. But I happen to know that those spaces mean I get a second translation of X plus 2.5 or 5/2 and Y plus 2.5 or 5/2. So this is 2 translations because it shrinks it into here, but then moves it after. And even though we're shrinking about this point in the center, it's 2 translations in order to make that happen on a graph. Now if it shrank towards the center of the graph, then it would only have that scale factor. But what I've put here is this other triangle, DEF. Remember, any translation has to hold its shape. While it's still a triangle, it's a completely different kind of triangle. So we can't prove that it's similar. Not using a translation, not using a reflection, a rotation, or a dilation. So we have to be capable of keeping track of all of those older skills. So it could be a good time to go back, review all of those transformations so that you know what can be done and how to do them. Remember, math rocks with a capital M.